Good morning, fourth grade. This is Ms. Kachibata. I am actually trying something a little different today. So I really would like you to be able to see me writing on the learning packet instead of just me kind of writing on a whiteboard behind me. So I'm going to try this. So we'll see how this goes today. So today is Tuesday, April 7th, 2020. And our joke of the day, what did Mr. Hamburger and Mrs. Hamburger name their daughter? Patty. Get it? Like a hamburger patty. All right. So we are on week 3, day 2, okay, in your packet. So our learning target today is I can compare two fractions with different numerators and denominators using appropriate mathematical symbols. So less than, greater than, or equal to. All right. And then I can also prove my fraction comparisons using visual models. Okay. So our fluency says, read the following, select one expression that doesn't belong. Provide details about your answer choice. So we did this, I think sometime last week, maybe the choose what doesn't belong. And kind of like last week, this week there are a couple different answers. Okay, so I'm just going to go over a couple ways you could have gone about figuring this out. So the first way is I'm looking at these expressions, okay? And I see in these expressions that in a lot of these expressions, there are 3 numbers in each one. So this one, let's see, how can I mark this up? So this one has 3 numbers right here. This equation right here has 3 numbers in it, and this expression, and this expression has 3 numbers in it, right? And I noticed that this one has 4. So that could be one reason that you say this expression doesn't belong right here because this expression has 4 digits in the expression, and all of these other ones only have 3. Okay, so you could write that incomplete sentences off to the side. So that is one way that you could have, looked at this problem. Another way is you could have, let's see, I'm still getting used to this. So you could have also said, okay, I'm going to actually solve these equations, right? So you could say, okay, 2 plus 4 plus 8. 4 plus 2 is 6. Now you have 6 plus 8. All right, 6 plus 8 gives you 14. Okay, so now we've solved that one. Then you could solve the next one, 7 plus 6 plus 7. Okay. 7 plus 6 is 13. And then 13 plus 7 is going to give you 20. All right. Then you could keep going and say, all right, now we have 6 plus 11 plus 5. Okay. This gives us 17, and 17 plus 5 is 22. All right, and then we have 2 plus 9 plus 4 plus 3. This gives us 11. Okay. This is going to give us 15. Pen's not working. There we go. And then our final answer is going to be 18. All right, so now you could look at these 4 problems and say, okay, now why do we think they don't belong? Is there anything that we can look at in the answer that tells us why one of these expressions wouldn't belong? Okay. So that could be one way. You could also look at the types of digits in each problem. Okay. And that could be anything, like in this expression, all of the digits are even. Okay. In this expression, only one of the digits is even. In this expression, only one of the digits is even. And in this expression, 2 of the digits are even. Right? So there's a couple different ways you could have gone about this. I'll leave it up kind of open to interpretation. Get creative. Maybe you and your siblings or your parents or whoever you're staying with thought of other reasons. So if you thought of another reason why the expression doesn't belong, go ahead and let me know. All right. So let's see. Moving on down, we're going to move on to our daily task now. Okay. So the daily task says read each task carefully and follow the directions. Make sure you write an explanation and show your work. Okay. So task A says, how does the value of a fraction change if you double its numerator? Explain your answer using words or pictures. Okay, so let's think about that. So I'm going to say, all right, I have the fraction 2/5. All right, and I'm going to go ahead and draw that over here as well. All right, and I'm going to shade in 2, and then I'm going to label that this is 1 whole. All right, so now I have 2/5 shown here. So if we double the numerator, that means we are going to multiply the numerator by 2. So if I double the numerator, this is now going to give me 4/5. All right, so now I'm going to go over here, and I'm also going to draw another tape diagram. I'm going to try and make it the same length. It's kind of hard to do this on an iPad. All right, and now I'm going to show my new fraction, 4/5. 1, 2, 3, 4. All right, and again, this whole thing is 1. So now I have 4/5 here. All right, so what happened? How does the value change here? All right, so I want us to think about, okay, well, I started with 2/5 right here up top, and then I doubled the numerator, and now I have 4/5. So I can see that the value increased, right? It got bigger. The value doubled. Instead of having 2/5 here, now I have 4/5 here, right? So the value doubles, right? It becomes a larger fraction, okay? So now if you want to write that in a complete sentence, you can use the sentence stem like, when you double the, sorry, I'm running out of room, numerator, and you can keep going, okay? All right, on task B, all right, how does the value change? How does the value of a fraction change if you double its denominator? So now it wants us to double the denominator. Explain your answer using words or pictures. So again, I'm going to take a fraction and I'm going to say, okay, let's use the same fraction. We're going to use 2/5, okay? And again, I'm going to come over here and I'm going to show this. Actually, I'm going to make that a little bigger, a little longer. I'm going to show this as 2/5. So again, 1, 2, 3, 4, 5. All right, and I'm going to shade in 2. Okay, and this whole thing is 1 whole. All right, so now I have 2/5. Now I need to double my denominator. Okay, so I'm going to take my denominator, which is 5, and I'm going to say, okay, 5 times 2 gives me 10. So now I have 2/10. Okay, I want to see how this changes the value. So I'm going to draw the same tape diagram, and I'm going to try and make it the same width, or the same length, I'm sorry. And then I'm going to try and line up where I divided it, the units inside, okay? But now I have to make it into 10 pieces. So I'm going to divide each one in half. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, and I'm going to shade in 2. Okay, now let's look. And again, this whole thing is 1. Let's look at these two tape diagrams, okay? I see that here, now that when I go back up to this problem, right, up here, when I doubled the numerator, my fraction got bigger, right? I had more pieces shaded in down here, okay? Now what happened is down on this problem, I had 2/5 right here, all right? But then when I doubled the denominator and I created tenths, I notice that I have less pieces shaded in here. Just looking at my model, I can see that 2/5 is greater than 2/10, right? Because I have this shaded in all the way here, and I have this shaded in just to right here, okay? So I can see that these 2/10 is only equal to this 1/5 right here. So the value, when I double my denominator, the value of the fraction actually gets smaller, right? So writing down that sentence stem again, just so you can explain your answer. When you double the denominator, and you can finish that sentence. Okay, our fraction got smaller. Why? Because we took those fifths and we actually broke them down into tenths, but our numerator didn't change, so we still only had 2 pieces shaded in, right? We created more pieces, but we only have 2 shaded in still. So it's a smaller fraction. All right? So now we're going to go, down to our task B. All right? And this says, order the following fractions from smallest to largest, all right? And I'm going to go back to a number line strategy that we used, and I'm going to do it that way because if you were sitting here trying to figure out, okay, how do I order these from smallest to largest? My first thought was, okay, let's create the same denominator, right? But finding the least common multiple between all of these fractions is really difficult, okay? It's not very easy. It's actually very big. The least common multiple between these fractions is 120. So that's a lot, right? So we're not going to use least common multiple here, but we are going to use what we know about fractions and using a number line, okay? So I'm going to draw a number line down here. All right. Now, I'm going to look at all of my fractions up here, okay? So all of these fractions I know are less than 1 whole because none of the fractions have a larger numerator than a denominator, right? So I know that all of these are going to be less than 1. So I'm going to label my number line 0, 1, and then in the middle I have 1/2, okay? Now, I'm going to start with 3/8. All right, I'm going to start with my first fraction, 3/8. So 3/8, I'm going to think, okay, the first thing I want to know about where it goes on this number line is 3/8 going to be less than 1/2 or greater than 1/2? So that at least I know where does it fall on the number line, okay? Is it going to fall over here before the 1/2 or is it going to fall over here after the 1/2, okay? And I know that, okay, what is half of eighths? If I have eighths, what's going to be halfway? I know that halfway is going to be 4/8, all right? So if that's the case, if halfway is 4/8, I'm going to say, okay, 3/8 is going to be about right here, all right? So we'll say 3/8 is about right there. It doesn't need to be exact, but we know that it's going to be about there, all right? Because if I was going to keep going, this could be 2/8 and this would be 1/8, right? And then, of course, this would be 4/8 right here. So I have my 3/8 there, all right? We'll leave it there for now. Now I'm going to go to my 1/3, okay? Now, 1/3 is pretty tricky. So I want to think, okay, I know that 1/3 is going to be before 1/2, right? But I don't know exactly where. Like, is it going to be before 3/8 or after 3/8? Now, this is where you can use those least common multiple between 2 fractions because that's a lot less, right? So if we say, okay, 3/8, let's see, 3/8 and 1/3. I want to know which one is larger. Where is 1/3 going to go before 3/8 or after? So I am going to use that strategy of finding the least common multiple, all right? And when you find the least common multiple, remember you could come over here and skip count. So say 3, 6, 9, 8, 16, 24, right? And eventually you're going to figure out that the least common multiple between 8 and 3 is 24, all right? Please remember to go ahead and pause the video so you can work ahead and then check your answer so that you're, still pushing yourself to remember the things that we learned before school was closed. All right, so now I'm going to say, okay, 8 times what gives me 24? 8 times 3. Whatever I do the bottom, I have to do up top. So 3 times 3 is going to give me 9 24ths. All right, and then I'm going to say 3 times what gives me 24? 3 times 8 gives me 24. Whatever I do the bottom, I have to do up top. So 1 times 8 is 8. All right, so now I have 9 24ths and 8 24ths. So I can see that 1/3 is going to be less than 3/8, right? It's going to come before 3/8 because 1/3 is the same as 8 24ths and 3/8 is the same as 9 24ths, right? And 8 is less than 9. So I'm going to say, okay, that means 1/3 is going to be about right here. Okay, it's going to be right before it, right? Because 8 24ths and 9 24ths is not that far apart. So I'm just going to mark 1/3 right before it. All right, so we're done there. Now, I want to go to 5/6. All right, now, thinking again about what I know. I know that 6/6 make 1 whole, okay? And I know that 0/6 makes 0. So what would be halfway if I'm talking about 6th? All right, I know that 3/6 would be at this halfway point. All right, so if 3/6 is at this halfway point and 6/6 is over here at 1, I know that 5/6 is going to be about right here, right? Kind of right before that 1 whole, 5/6. Okay, because 4/6 would be about right here after the 1/2. All right, so now I have my 5/6 there, right? That one's done. So the only one I have left now is the 2/5. All right. Now again, let's think about that 1/2 benchmark. Okay. I know that 5 is not an even number, so it's going to be hard to find that halfway. But I do know that 2/5 is going to be a little before 1/2, right? So if you think about, okay, how can I get close to 1/2? 2 plus 2 gives me 4, right? So I want to know, okay, what's halfway between 5? It's going to be about 2.5, right? So I know that 2/5 is going to be somewhere over here, all right? But I need to know, again, where is it going to fall in comparison to 3/8? We can start there, okay? So again, I'm going to come down here and I'm going to say, all right, I have 2/5 and I have 3/8. I want to know if 2/5 is greater than 3/8 or less than 3/8. Where is it going to fall? Okay, so I'm going to find that least common multiple. And when I find the least common multiple between 5 and 8, you should find that it is 40. Okay. Now, same thing. I'm going to say 5 times what gives me 40? 5 times 8. And whatever I do the bottom, I'm going to do up top. So 2 times 8 is 16. All right. And now I'm going to do the same thing with 3/8. So 8 times what gives me 40? 8 times 5. And whatever I do the bottom, I'm going to do up top. So 3 times 5 is 15. All right, so I can see that 2/5 is greater than 3/8 because 16/40 is greater than 15/40. So I'm going to say, okay, that means that 2/5 has to fall about right here, right before the 1/2, but after the 3/8. Okay, so now that we have all of our fractions on the number line, we can put them in order from, what did it say? From smallest to largest. All right, so I'm going to start with my smallest. So what fraction came first on my number line? I can see that 1/3 came first. All right, so I'm going to say, okay, 1/3 is the smallest. All right. Then I would say 3/8 came next. All right. Then I can see that 2/5 came next. And then I can see that 5/6 came last. All right. I have now put my fractions in order from smallest to largest. All right. Using a variety of strategies, right? I used my number line strategy. I used my least common multiple strategy. And I was able to finally figure out what order they all go in. It's kind of like a puzzle. Okay. Going down to our daily closing, students list at least, they make some typos here. So at least 2, I'll say 2. Students list at least 2 key ideas from the lesson and why they were important. For example, rounding is important because, all right? So I'm going to go ahead and give you some prompts based on what we did, all right? So if you're going to write what you took away from this lesson, if we go back up to our learning targets, remember our learning target was that you can compare two fractions with different numerators and different denominators, all right? And then you can prove your fraction comparisons using visual models. So to list the key ideas, you could say one just example, whatever you write is okay, but just giving you some prompts. You could say, all right, using a number line to order fractions is helpful because, sorry, it's hard to write on this thing. Because why? How did it help you? Okay. You could say, finding the LCM helps me compare fractions by, okay, ... How does it help you? Okay. So whatever the key ideas were that you took away from this lesson, go ahead and write them down. 1 or 2 key ideas is fine. And you are done with day 2 for today. All right. Oops. So I'm still getting used to doing this. Let me know what you think on Instagram or commenting on the YouTube video, whichever is easier, or texting me. I just want to know what you think is better in terms of, working out these problems and helping you, work through your stuff. I will keep you posted in terms of work for next week and what's going to be coming up in the next few weeks while we're still out of school. But yes, please reach out if you need any help or if you have any questions. All right. So I will see you guys tomorrow. Have a great day. Bye.